Hey math kids, we're going to talk about rates of change today. We'll start just with this. dy dx gives the rate of change in y with respect to x. Okay, and so we'll start with this story problem. According to a psychologist, the ability of a child to understand spatial concepts is given by a is equal to 1/3 square root of t, where t is years, and it's defined as between 5 and 18 years old. Part A asks us to find the rate of improvement in ability to understand spatial concepts when a child is 9 years old. So we're just going to take the derivative of this. So first I'm just going to rewrite it as t to the 1/2, like that. And so the derivative is going to be 1/3 times 1/2 t to the negative 1/2. If we plug in 9, like we're asked to on this one, we're going to get 1/6 9 to the negative 1/2. Negative 1/2 is just a square root on the bottom of a fraction. And so that's really just 3. So we get 1/18. So part A gave us 1/18. Same thing with 16, same question. So I'm just going to change this 9 to a 16, which means 1/6 times 4. So 1/24 for that one. Okay, part B says show that dA dt is greater than 0 on this entire interval. Okay, so I'm going to take it from here essentially. So it's 1/6 square root of t, and we need to show, because this is our derivative, a square root can never give us a negative number out of it. And so since we have a constant that's positive times something that's always positive, positive times positive is always greater than 0. And so this means that the ability to understand spatial concepts increases with age. So as you get older, in between 5 and 18 years old, your ability to understand spatial concepts will continually grow. Now, we want to find d squared a dt squared is less than 0, or in other words, the second derivative. Once again, we're going to look on this interval, and we want to show that it's always negative. So what I'm going to do is I'm going to take it from here. So it's 1/6 t to the negative 1/2, and then take the derivative again. So that's negative 1/2 times 1/6 t to the negative 3/2. Move that over. So that's negative 1/12, and then this is going to be t to the 3rd underneath a square root. Now this is always negative, but this is always positive, so negative times positive will always give us a negative number. And what this means is, though we already showed that a person will continually understand spatial concepts more and more and more as they get older within this range, the amount that they learn each year is decreasing. So that's what our second derivative tells us. So they're always learning more, but the amount they learn is decreasing. Okay, the cost in dollars of producing X items in a factory each day is given by this function. Okay, it wants us to find C prime of X, which is called the marginal cost. Okay, so we just take the derivative, constant goes away, this becomes 12. we bring down, do 8 times 0.8 x to the negative 0.2. So we just subtract 1 from there. Okay, if I just simplify that, we end up with that, and that's going to be dollars per item. Okay, so that's our answer on part A. Now B, find the marginal cost when 150 items are produced. So we're just going to plug in 150 here. So 12 plus 6.4, 150. Okay, we just plug that into a calculator and we round to the nearest cent, and we end up with that. So once again, I just plugged in the 150 to this function, and we ended up with that. Now it wants us to find C of 151 minus C of 150 and compare it to this answer. Okay, so if we plug in 150 up here, I would just use a calculator, and if we do that, we get 11754.87, just rounding to the nearest cent. And then for 150, we just plug in, oh, whoops, that was, I did plug in 150. Sorry, that one is 1174052. Then for the first one, we plug this in, and when we do that, we get 11754.87. Subtract those, and we end up with 14.35. Okay, so on the first one, we're going to kind of interpret the result. We got the same thing on both of them. We're going to interpret the results. Okay, so what this is telling us, this marginal cost, it's telling us the rate that it would cost to increase to make the next item that we're so directly from the book, it says this is the rate at which the costs are increasing with respect to the production level X when 150 items are made per day. It gives an estimate of the cost of making the 151st item each day. So if we wanted to make one more item, it would cost us $14.35, and then we have to decide, is that worth it? And then this is the actual cost of making the 151st item each day. So this is an estimate, and this is exact. Now, in this case, it ended up being the same thing, but it won't necessarily always be exactly the same. Okay, Kathy is using a compass to draw a circle. The arm with the needle is 8 centimeters long. Okay, so we have a compass. Here's the pencil side. Here's the needle side. And so this one is 8 centimeters long. And the arm with the pencil is 9 centimeters long. The angle between is theta. It says write the radius of the circle to be drawn in terms of theta. Okay, so this is going to be the radius. So I'll just call that R. And we're going to use the law of cosines, or the cosine rule, and because we have 3 sides that we're interested in and a single angle. And so just as a refresher, we're going to get that, I guess, cosine C. Okay, so this is our R, 9, 8, 0.98 cosine theta. Okay, now we need to solve for r, but we can simplify a little bit. So 81 plus 64 minus, let's see, 72 times 2. Okay, so I'm going to use a calculator. Okay, so that's 144. Okay, combine those, we get 145. Now, it's really tempting right here just to do 145 minus 144 and get 1, but because of order of operations, we can't do that. So we're just going to solve for r. Okay. And yeah. Now B says, so that's the answer for A. Now B says, hence find the rate of change in R with respect to theta when theta is equal to 60 degrees. Okay, so essentially they're asking us to find dr d theta, which is just the first derivative. So if we think of R as 145 minus 144 cosine theta raised to the 1/2, we can take the derivative a little bit easier. So we bring 1/2 down in front, rewrite the inside, and then we reduce this by 1. And then we multiply by the derivative of the inside, and I ran out of room. So this thing is going to be multiplied by negative 144 times negative sine theta. Okay. Now let me write that out. So these negatives will cancel. So I have 144 sine theta times by 1/2 145 minus 144 cosine theta raised to the negative 1/2. Okay, so if I divide those, I get 72 sine theta, and then I'm going to put this on the bottom under a square root, and this is our dr d theta. Okay. Now they want us to look at this when theta is equal to 60 degrees. 60 degrees is the same thing as pi thirds. And so if we look at our unit circle, pi thirds is the third tick mark right here. And that's going to be 1/2 square root of 3 halves. So sine is going to be 72 times square root of 3 halves. And then on the bottom, we get 145 minus 144. Cosine is 1/2. And then if we just plug all of this into a calculator, we're going to end up with let's see. No, let's actually do it together. So we're going to have 72 times square root of 3 divided by 2. So the top is 62.4. Then the bottom, we're going to get 145 minus 144 times 0.5. So square root of 73. Then if we do 62.4 divided by square root 73, we get 7.30, is that what it was? Yeah. So 7.30 centimeters per radian. And then if you happen to approach this using degrees instead of radians, we would have got 0.127 centimeters per degree. If you need additional help, please come to Math Lab. Until then, calculator.